I can
Okay.
record it. I think it should be starting.
Okay, and then in addition to that, when we're done, if you could send me the link for that, because I don't know if you've noticed that the Ezra Facebook page, they've been sharing them so other people can see what's going on and things like that. And so also, I really want to emphasize this isn't this isn't being judged for points or anything like that. This is all about seeing if you have or will have very soon a rocket that is ready to fly and able to do that safely. So that's kind of it. And I do have a couple of questions that I routinely ask when I'm doing safety reviews of rockets. It might be difficult to do over a virtual environment like this, but I also talk too much. So I'm going to try really hard to sit on my hands and keep my mouth shut and listen to what you have to present about where you are with your rocket and all that. And then when you're done presenting, maybe ask a few questions and we'll call it a go. So
okay,
yeah, it's all yours.
Yeah, so I figured the best way we do this, I'll go subsystem by subsystem. I'll show what we've built, what we have left to do, and then I figured we might as well do questions then, so it's like fresh in our minds, and my sub-team lead who's responsible can handle those. So first, to start off, I'll do aerostructures. Yeah, this is the rocket here. It's disassembled. We are painting it white this Friday, just because obviously the desert, we don't want heat. Yep. We've got 4 fins. These fins are fiberglass frames with a foam core, and then a carbon fiber tip-to-tip layup over that. This is our motor tube. It was 2 sections, but we have a coupling tube that goes 1.5 body tube diameters on either side, and then it's been fully epoxied and kept together, so that remains solid. And then over here, so we have our nose cone. That is, this is all carbon fiber. What needs to be finished with it is this coupling tube is going to be epoxied inside and then beveled down like we fit in. So this is also going to be a permanent like access to the shoulder. Each connection, has a carbon fiber coupling tube inside of it. We tried to get 1.5 body tube diameters for each one, except for this middle, the avionics bay, that only goes 1 body tube diameter inside. So it goes about halfway. Here we have the lower chute tube, upper chute tube, and the avionics bay, also made of carbon fiber. And to be able to transmit out of it, we have, it still needs to be modified and cut, but we are moving the antennas outside of the body and they're fastened to the side. Ideally, the plan was to do fiberglass, but just because of materials and time, this is what we're trying. And we've done testing with those antennas to make sure they work. And then also just for the GPS chips on the boards, a hole will be cut out and they're kind of right up against the wall so that they can transmit directly outside. I think that, that's a high level review of the aerostructures system. We also have our bulkheads. And so we've actually made our own bulkheads out of carbon fiber as opposed to last year we used aluminum. What still needs to be done with these is on Thursday, I'm going in with the shop lead for our school, and we need to drill around the sides to put in threaded inserts so that they can go obviously be secured actually in the rocket, and then need to be drilled the whole placement for the recovery hardware and also the motor tube hardware, and then also the payload hardware. So I was wondering, do you have any questions now about aerostructures?
No, I think you kind of answered what I was going to ask when you started talking about this thing is tip to tip carbon fiber and worried about attenuation of radio signal, and you explained how you're doing that. I trust you'll probably do some kind of test after you've cut those out and things to assure that you have communication.
Yep. Yeah, absolutely. We'll be this week or next week, if the after paintings, we'll be doing a full assembled rocket and then see if we can communicate with them. Okay, so I'll go on to the recovery system now. We have dual deployment of a drogue chute and then a main chute. Of course, drogue chute at Apogee, main chute at the 1500 feet. We use a black powder ejection system, the same one that we used last year and was completely successful with that rocket. So how we do that, we have our 3D printed black powder canisters that we fit a foam, a foam ejection plug into it that and that extends out, and then we put these caps on, and then they get wrapped in electrical tape. And the thinking behind that is we're putting as much compression onto the powder as we can to make sure that we get a full ignition. And then the black powder, or the electrical tape, is to provide some amount of spring so that even as it initially starts to ignite, that keeps it slightly longer so it doesn't just blast out unburnt powder, and keeps it longer. And then that snaps the electrical tape. Our chute tubes are PVC that we have, and this is kind of one concern that I asked on the HeroX site, but I didn't get a response to. I know that PVC is not allowed material for the body of the rocket. I'm not sure if that's just for the body of the rocket and pieces that need some kind of structural integrity because of obviously the warping with heat. So yeah, these are our chute tubes that we use inside the rocket. I did just find that the blue tube that we used last year just came back in stock yesterday. So if we needed to change that, we can. If you think this is a not allowed material.
I absolutely don't know. So I'm going to have to, I wish I could say that I had every line of the DTEG committed to memory, but as you know, it also changes. So, but I will ask.
Okay. I might be able to answer that, Bill.
Okay.
I don't have it from memory, but I do remember that for PVC and certain metals, the reason for a lot of it is that if something explodes, it will fracture out into tiny little pieces and
shards. Yeah.
Particularly PVC, it's hard to show up on X-rays and can be quite disastrous if someone got hurt with it, rather than some certain other metals. I'm not sure if that will still apply to this. You can also use cardboard in any sense. Centering tubes shouldn't have much structural impact.
Yeah.
As the name says. But yeah, I don't know how that is in the DTEG.
Okay, I'll keep. I saw that other teams were allowed it for. They had some aesthetic reason to use PVC on the outside, and that. But I'll look into that later. We use of course. We mount all of our hardware onto our bulkheads, and because we don't have those holes drilled yet, I have what we used last year to show the entire setup. So this is what goes into the tubes. We have a main and backup ejection charge, and then our closed loop forward eye bolts. They're kept in on the back, and these two wires come out, and then this would connect to the avionics bay.
Could I see the other end of that eye bolt? Just where it goes through. The other side. Yeah. Okay. Right. And this red coupler is made out of what type of material?
This is aluminum. This isn't the one
aluminum. Okay. Never mind then. I was gonna, we like to see a nice large washer on the other side of that to prevent it pulling through. You're not going to pull through aluminum.
So actually, that's good to know, because this is the one from last year that was just showing how it's connected. Right. But this will be replaced with the carbon fiber one.
Okay. All right. So you're familiar with what we call fender washers? If you go to a hardware store, a fender washer is a large diameter washer with a small hole in it. That would well, you're from Canada. Basically, it works like a snowshoe, right? You're trying to put a whole bunch of area there to just so as to assure that you don't pull that eye bolt through. That's a critical point.
Okay. All right. Noted. We will make that change. So then parachutes, we have 30-inch drogue chute, then 84-inch main parachute. One modification, so last year for the drogue chute, we have swivel links on the end of both parachutes, but this drogue chute one is very small. So we will be modifying, and we tested with last year's drogue chute. We have modifying by putting on a much larger swivel link, which allows us to use also much larger quick links. That's to deal with that strength issue. Yeah, all connection points for the recovery harness have swivel links that then connect to our quick links that then to the eye bolt. These are all, I can't remember the exact strength to them, but we know that they're appropriately sized. Strength. And then our shock cords. This is another, these are our new shock cords, haven't come in yet. These are the ones that we used last year, but we have the strongest ones now, the strongest ones that we could find from this supplier. They're braided Kevlar. They have the loop to connect the parachute 1/3 of the way up to be able to make sure that they, and we offset them the right way so the parts aren't hitting each other. Last year's issue was that judges did not believe, I think based on just the thickness of this cord, they didn't have much confidence in it. So that's why we've gone up to one that has, it's weighted for rockets of over 200 pounds. Yeah, and it's much thicker.
Yeah, if it's Kevlar,
Yeah.
you know, I mean, like for instance, I don't know who your vendor is, but Rocket Man, his cords will look rather thin, but if you look at the ratings on them, they're fantastically strong. So
Yeah.
If someone questions you on that, you might want to just have the specs from the website or something like that to show them. I personally, if I was doing your safety review, I would be as equally concerned about their length as I am with their strength. So
Okay.
how long are your cords?
They're 20 feet long, both of them.
Okay.
Yeah, we looked forward to get, so the total recovery hardness will be about 4 times longer than the rocket itself.
Okay.
Yeah. So that's it for the recovery system. Yeah, I just wanted, do you have any main or concerns that have shown up there?
Ron, do you have anything you want? I pointed out, you know, the eye bolts. You have the right kind of eye bolts. We want the fender washer behind them so they don't pull through. You have the right strength on them, and we like them to have some length. So, yeah.
All right.
Looks good. Just one question. Your hopefully drogue is popping at the center of your rocket, not the nose cone tip or nose cone.
Yeah. Yeah. So this is the drogue chute tube here, and this connects to the motor tube.
Okay, cool.
Which is popping. Okay, nice. So then we'll go on to the avionics bay, and this I'm going to need Kushi, our avionics lead, to do some of the talking for me, because this is definitely one of my weaker areas. So I could show. This is just glued today. This is this avionics based structure. You mount the flight computer one on each side. Yeah, and then these holes just for wires to go through. So, and also mounting our batteries. Kushi, could you run through what the boards are?
Yeah, so the 2 flight computers, like Will mentioned, would go on there. And then the antennas are connected with an SMA cable to make sure that they extend to the outside of the rocket. And then they'll be screwed on with another type of clip that goes on the outside, like a hook, to hold it in place. And we'll make sure that it's, again, that would be able to transmit RF as well. There wouldn't be any issues with interference. And then the 2 flight computers we have, our main is going to be the AIM Extra, which operates on the 915 megahertz frequency. And then our redundant is the Telemetrum, which operates on the 435 frequency range. And we do have like a ham radio license, so we're all good with that. And the AIM Extra comes with its own handheld receiver. So that one is going to just be connected directly to the computer, to the software to be able to receive data that way. We did do some range tests and we got pretty good range tests with some like trees and stuff in the area, still got some pretty good range. So we should be okay for the 30K feet. And then with the redundant flight computer, we would have to use like the Yagi antenna because that one doesn't come with its own system. So yeah.
That's fine. You'll see a lot of them out there. So
Yeah.
Yep. Yeah, and so yeah, as mentioned, that's to finish the avionics side, we just need to be cutting our outer holes and then doing all those tests to make sure that everything's working perfectly. Okay, on to our propulsion sub-team. Dylan, if you could help me out explaining. So yeah, this is our motor tube. We have all of the mounting hardware for our motor. I'm also Thursday with our shop lead. I'll be machining out an aluminum retaining ring, and we fit our motor in all together. We have 3D printed centering rings that we just need to glue inside once we've gotten this painted. Yeah, Dylan, if you can go over.
So, but help me understand it real quick. Those centering rings, are they going directly against the motor casing, or do you have a motor tube in there?
They go against the motor casing.
Okay, because motor casing gets really hot.
Or I should say they don't actually go up and touch it. This is more for the mounting. There is a space in between.
Okay.
So yeah, sorry, I just meant there's nothing in between the centering rings and the motor tube or casing. It's more centering for then when we're mounting on the couplers onto it, but there is the space around it, so it wouldn't melt.
Okay. Okay.
And when it comes to just the specifics of just the products that we're using, we're doing a COTS motor competition, obviously, for 30,000 feet. So we're going to go with the CTI 3400 motor, just high impulse. And that's a 98 millimeter diameter motor. So it's using the 6XL or 6GXL casing.
Yep. Where did you find an 3400? They're kind of rare right now.
Well, Jessica,
as soon as we got that first email, I like scoured and was on like Animal Motor Works like no tomorrow. Got too many charges for long distance calling, but managed to secure one luckily. Okay.
All right. I shared some stuff with Will, and if this has already been shared, just say yeah, shut me up. But the 3400, it requires you to bond those grains into the phenolic. So you have to think ahead and plan ahead to take those propellant grains and bond them inside of the phenolic, and that's with it actually comes with a two-part. I don't want to call it epoxy because it's kind of a rubbery material, but you're going to need a place to do that, and it's not a hotel room. Okay, so just think ahead on that. I personally have done 11 3400s and all of them successful. So they don't. I think a lot of what you hear as far as them catoing and stuff is sort of legendary, especially now that you're required to bond them. So again, it comes with a two-part, a glue and a hardener. If this rocket motor is old, a couple of years old, there's a possibility that the hardener that you have to pour in might have gelled up a little bit and it won't pour out very good. So I think it would be a good insurance policy to buy yourself a bottle of Elmer's Glue All Max and just have that in case you can't use the bonding agent that comes with that motor. So, that's a $5 insurance policy to have that in case. But yeah, so
that's good to know. Thank you.
Yep. Yep. So think ahead, plan ahead. It requires 24 hours of curing. And then you'll probably case the motor out in the field. So, okay. See, I talk too much.
No, thank you. Yeah, I missed that. Okay. I think that is, and then payload, we have a CubeSat payload. Our payload lead supposed to be on this call, wasn't able to make it. Can't, I haven't been as a part of that subteam. It goes into the nose cone, screwed on to one of the bulkheads. It's reading data about our positioning, and it's supposed to be testing for like eventually creating our own flight computer. Yeah, non-deployable. Yeah. Yeah, so that's it with what we have done. We should be complete the rocket like end of May at the latest. Like we don't have any big build stuff left. It's more just machining or cutting out parts for testing. So yeah.
Mm-hmm. Yep.
Yeah.
Yeah, it's okay that you're not ready to go. You know,
Yeah.
I think really the whole point of doing these video reviews and stuff like that is all of us have seen this where people are in the parking lot gluing fins to their rocket, you know, at
Right.
spaceport, and you're obviously past that point, and I'm quite certain that you're going to have a rocket ready to fly. I appreciate your choice of color, because you're going to be in an unrelenting sun.
Mhm.
It's going to be really hot, and all the solid pads are in one location. We used to have A, B in one and then C in the other. All of them are going to be together. So it's not, I wouldn't be surprised if some rockets are sitting on the pad, you know, for 2 hours, you know, with the sun beating down on them. So white is a wonderful choice of color for your rocket. So
Very nice. Yeah,
Yep.
last year's was all black. So
okay.
Yeah, we
made the
had
correction.
issues with that, so also
We're-
hence the change.
Was yours one of the ones that deployed its charge on the pad?
No, it was just for fitting all like the coupling tubes and stuff.
Yep.
It was really tight, and we think that the carbon might have expanded or the epoxy gelled
Yep.
a little bit.
Yep.
So yeah, it was
Yep.
quite the assembly process.
Another thing that I think people fail to appreciate is that's a very dusty environment. And if you get enough dust on your couplers, the coefficient of friction really, really goes up. So I would have some paper towels and things like that. And you know, my students, they routinely do this when they're getting ready to put everything together. They wipe both the inside of the tube and that outside of the coupler that's going to go together to minimize the dust on them so that they don't stick on you.
Right.
Mm-hmm.
Okay.
I just have one comment lastly. And I'm sure you guys have already kind of considered this. For sticking out your antenna for the avionics, in my personal experience, it's in a very similar rocket as this, that you'll get good signal. Well, you'll get intermittent signal just because with as the body tube rotates, you'll lose a little bit of signal as it gets blocked out by the rest of your carbon fiber. When it lands, there's a pretty good chance your antenna might be on the ground and you will lose signal altogether. Just something to consider, food for thought, especially on your avionics team. And as you guys go recover out in the field, be considerate that it might take a little bit extra time to find it. And to make sure your antenna isn't in a critical way that as it's detached won't get sheared off during launch or when it hits the ground.
Mm-hmm.
Right.
Ram,
Yeah,
I wonder, I was gonna say, I wonder if it would make sense to make that antenna in line with one of the fins, you know, because
antenna, yeah.
Well, I'm just saying in line with one of them, just because when the rocket comes to rest, it's probably going to be between two fins, you know, and so if you're in that surface body that's between two fins, you have a 33.33% chance that it's going to be face down. Whereas if it was in line with one of the sides of the fins, you have a much lower chance that it would be face down and not communicating. So
Right.
good observation. You learned that from experience.
Yeah.
Yeah. Okay.
Yeah. And we have our two, our main and backup that will be on opposite sides
Oh, okay.
too.
Awesome.
So that will keep it hopefully
Okay.
up there.
And also like our main flight computer gives like coordinates of like so that might help us find it as well. Like based on how it progresses through the flight and where it lands, we might be able to like catch like if we get a packet that's
Yeah.
just before, we might be able to like go off of that.
Okay. All right. Just an overall question. I mean, I'm noticing that you have, like for instance, your payload tube. It looks like it's 3 sections. You know that, yeah. Instead of one big long piece of, is that just because of like the length of your mandrel or your material, or?
So this one is, so right here is like the separation point because these are, this is the main tube, body tube.
Okay.
Or,
All right.
Or parachute tubes here and the MI space. So that's
Okay.
how it separates. Or, but yeah, for the motor, it was just the length of our mandrel kept it. So like this is glued together.
Okay.
Because of
All right.
that.
The old 3400 is obviously much longer than that section that you just showed there. It's going to be working its way up into the booster tube. So
Yeah. So this one, yeah, I've test fitted into this tube, and it's slightly. The tube is longer than the motor.
okay, good.
So, yeah.
Good. So, some of the things that like when you do the safety review on, I think that'll be Tuesday, the day of the convention, when you're going through there. Some of the things that I look for is, first of all, because you made all those body tubes yourself, right? They weren't, it's going to sound funny, but I'll just reach around and give the thing a squeeze to make sure that it is physically rigid.
I've jumped on them
Okay.
Well,
and
we,
no
well,
flex.
we did
Okay.
a compression test against the body, and it took 800 pounds before it cracked.
Okay, that's much stronger than my squeeze, but
Yeah.
and that increases our confidence that yes, this is a good build and it's going to work out. Usually, I like people to show me where the tubes are vented. So just
Right.
yeah. I mean, I've had people come for the safety reviews and they're not vented, and they run out the parking lot, grab a drill, and now it's vented. It's
Right.
it's no big deal. It's a quick, easy fix, but like to know where those are. Once you assemble your whole rocket, very often what I'll do is I'll grab the rocket by the tip and just lift straight up and see if there's any bend to the rocket. You mentioned you have 1.5 caliber couplers, so I'm thinking yours is going to be pretty rigid. But I've had a couple of rockets that are loose like a pool noodle, and when they start flying, they go all over the place. So we want to make sure that it's a nice, nice tight connections. What are you using for your motor retainer?
Sorry, on this end with.
Yeah, right. Yeah. Once you put the motor in, what's holding it in? Yeah.
So we have an aluminum part that we're machining and then epoxying it on. That has thread holes, and then it has the part that like connects onto the motor itself to get.
Okay, so you're making your own retainer. So okay.
Yeah.
Okay.
Yeah.
All right. You showed me the eye bolts, and that's good. We talked about wanting large diameter washers. Told me the length of your shock cords. And okay, your avionics, right now it's just a board. You haven't put your electronics on it. When I'm looking at a rocket, if the wiring is nice and neat, that increases my confidence that everything is in the right place. And then also the wires that you strip for the connections, strip them just enough so that when you insert them, there's no exposed wire. You know, that you don't want to see any shiny from those connections. If I saw that on a safety review, you know, you might even be able to just pull them out and clip a little off the end and put them right back in again. But you know, go ahead and do that. Bram, do you have any other questions for these guys?
Sure. Yeah. Actually, your comments on the cables made me think of a couple. But just when you're connecting the cords, it's another kind of food for thought. Is just make sure they're terminal connectors, depending on what you guys are doing. I think you said them before. Just make sure they're rigid. Obviously, there's quite a lot of G, especially on an O motor. You'll be going quite fast. They can really get pulled out of the simple little screw terminal connections. Hot gluing or another way that just seats them in there for strong connection is not a bad way to go. Especially if something's sticking on the outside, you don't want that shearing off. And then the other thing was, I think I'm not sure if it's still in the DTAG or it's still in the requirements to do some deployment testing just before you guys go out. And I know you guys don't have it all together just yet, but is there plans to get deployment testing done before the competition or either at the competition, and what shear pins you guys are kind of using just to make sure?
Yep. So not this weekend, but the weekend after, my recovery lead Russell is coming up, and that's when we're doing our tests. We have nylon M4 shear pins. I don't remember the exact strength on them. Yeah, we'll be doing those tests. It's the recovery system is almost exactly the same as the one we did last year for our rocket. So yeah, we'll repeat those tests, but we expect the same results.
I have to plead ignorance on this. Is black powder available in Canada? You're able, I mean, because some of our international teams are unable to get it. We have to do all the testing at Spaceport.
So yeah, actually we found pretty much the last bottle of 4F black powder in all of Ontario last year.
Okay.
And that's we haven't found that, which should last us 100 years. So yeah, we do the testing here.
Okay. All right. Terrific. So Bram, do you have any other questions you want to?
No, I mean, seems pretty good. Well, you guys are on the right track, yeah.
Yep. And do you have any questions for us? It sounds like you're all veterans of Spaceport, so you know what to expect. I do like to remind people that it is incredibly hot and incredibly dry, and if you're not drinking a lot of fluid when you're there, you're gonna dehydrate, and we'll lift you off the ground and bring you over to the tent, and they'll start an IV. So stay hydrated. That's probably the most important thing to having a safe, enjoyable experience at Spaceport.
I wanted to ask one thing actually.
Sure.
Last year was actually our first Spaceport, as I mentioned before, and I was propulsion lead. So we had actually some assistance with assembling our motor, and I was wondering if you guys would be available or to possibly help us with that, because I've never actually had to bond grains before.
Like I say, I've done 11 03400s. So,
especially with the experience.
Yeah. So I'm more than happy to. I will. I have Will's email. I don't know if I have anyone else's email. I will get you my cell phone number, because that's probably the best way to get a hold of people there. And I will actually have a couple of students with me who have bonded them, and I can't promise for them, you know. But last year, 2 of my students came with me, and we went to someone who had an 03400 who'd never done it before, and we did that. Bram, have you done any?
I haven't bonded, but I've assembled quite a array of larger motors.
Okay. All right. Okay. Yep.
Yeah,
You know,
the help
really
would be greatly appreciated.
Sure, happy to. The key to success on the 03400 is have everything laid out and check all the grains to make sure they slide in, you know, because the last thing you want to do is find that one is too tight when you're starting to slide, you know. So you test, make sure they all fit correctly. And then as soon as you mix those 2 ingredients, the clock is ticking. You know, you have a finite amount of time that it stays, you know, before it hardens and you can't, you know, go. So you don't have to rush. You don't have to race to get it together. but you don't have extra time. So you want everything laid out and everything planned. The grain that is closest to the nozzle is has a little wider opening through the middle of it, so the order of the grains are important. Like at least the last one. I think the other 5 you could mix them any direction you want, but that last one you have to make sure that that's closest to the nozzle. So right now I think what you need to do is start thinking about where you're going to bond those grains, because it's not just that you have a place that you can set up and do it, but next that you have to have a place where you can set that that phenolic vertical, to sit overnight. So think about where that, I don't know if you're the one I did last year, they rented an Airbnb and it was in a garage, so they had like the ideal situation. Yeah.
Okay. Yeah, that's great.
Mm-hmm. But yeah, I'll send Will my cell phone and have to do that. I also think there's a couple of videos online where people will, I don't do anything without looking at YouTube, so yeah. Okay.
As far as questions, I don't have any. My biggest concern was hearing feedback for the avionics space setup. But that's it. I guess any of my sub-team leads, do you guys have anything else you need to ask?
Can you hear me?
Yes.
Yeah, so I just want to, sorry for being a little bit late, but I wanted to talk about the payload. So we are using our metal sheets to build the body of the payload. I don't know if you can.
It's blurring in and out, but that's okay. Yeah. Yep.
And we are using MQ6050 for gyro and acceleration, BMP 280 for pressure sensing, LMDT35 for temperature sensor, and then VL53 to see the distance from launch pad to the very end where it lands. And it is all connected to an Arduino. And we have used a prototype board to mount everything, soldered everything. Let me just move the blur so it's easy to show. Yeah, so it's just all mounted in one PCB board, prototype board, and it will be in different different metal sheets that it's ported on, and then it's just gonna be mounted all together.
Fantastic. Your payload isn't deployed. Your payload stays on board the entire.
Yes.
Okay. Yeah. All right. Good.
That's all. Just wanted to mention that.
Yep. Yeah. Well, like I say, if you had a payload that's deployed, that just adds a layer of complexity to the whole thing for safety and stuff like that. So, okay. All right. Well, thank you for everyone for taking out time, and Bram, thank you for showing up.
Sorry, it's a little late.
Ezra wanted us to have 2 reviewers looking at these, and I put out a message saying, hey, who's going to help me do mine? And Bram he must really like rockets and wants to get out there and see what everyone's doing and things like that. But if you have any questions between now and competition time, you have my, Will and I have corresponded a little bit, and if I don't know the answer, I'll try to get it for you. And looking forward to seeing you there. Like I say, tonight after you stop recording this, if you can send me that link so that the Ezra folks can get that on their page, that would be fantastic. So,
perfect.
All right.
All right. Yeah. Thank you so much.
Okay. Very good. See you in July or June, not July. Don't come in July.
Yeah.
So,
all right. We'll
okay.
see you then.
Yep. Cheers.
Yeah.
Yep. Bye.